Please shut your MacBooks and I'll whip through a couple of things that you should be well past or onto. Okay, so distributive law 3 involved 5C. You can see on the board at mathematics for homework I wanted you down to the commencement of 5D. Now I'm aware that some of you aren't close to that, which, you know, I'm not going to bang on about, but you needed to have done a fair bit of homework, so I want everybody at least out of 5B. So 5C discusses the fact that if we were to have the same coefficient or pronumeral at the front and the same at the back, so x and x, 3 and 3, if the only difference is the plus and minus, then we square the first one and we square the second one. So we square the x and we square the 3. In this one, they're both the same. A and A are the same, 4 and 4. So it's that rule that says if we have A plus B, A take B, and we're multiplying them, a shortcut to solving that is that there. Okay? So that was 5C. Who has started and or finished 5C? Started and or finished. If I can just see a show of hands. Yep. So you people, you should be relatively familiar with that. Okay. 5D. 5D has another law. And 5D's law, can you remind me if I've been through this with you guys before at all? I think. Let's go again. Okay. That law says that if we have a bracket that's all squared, then we square the first coefficient or number, which is there. We square the second coefficient or number, which is there. And we add 2 times the first times the second. Okay? Now another way of looking at that, at this here, would be A plus B, wouldn't it? Because A plus B all squared, it means you've got 2 of them. And you got one there and one there. So we could expand it like that. And what process would we use now? Starts with an F. Foil. We would use foil there. Now if I was to do foil there, you would find that it would work out to be exactly this. It's just a shortcut. Okay? You teenagers, you do like shortcuts, don't you? Mm-hmm. Yeah? Short is better than long. The only consideration that you need to think about is that when there's a subtraction sign in there, okay, so that's the only difference. When there's a subtraction sign in there, the only difference or impact that has is a subtraction sign in your shortcut. This is your shortcut here, a squared plus 2ab plus b squared. This one will be a squared, you're still squaring that first one. Take 2 multiplied by the first one, multiplied by the second one. Now what's the important thing to remember with the sign? Is it goes with the b. So that'd be 2 times a times the negative b plus b all squared. Okay? Again with these, practice makes it a little bit more understandable. But I'm just trying to explain what that means and the reason why this is important, that it's a shortcut for you, rather than go through the FOIL process. If you're in 2C, or if you're in if you're in 5C or 5D, can you now go on with your learning? Taylor, I'd really appreciate it, a bit like our lesson before, if you could concentrate here. It's for your learning and your benefit. What's your backhanded comment? Sorry? Maybe if your eyes are this way, I would know that then. My apologies, I must have been wrong again. Now, further expansion. Who's in further expansion? Is anybody in further expansion? Yep, just you two? Okay. And plumbing. So I'm just going to go through further expansion with you. Okay, really quickly. Yep. Okay, Lee, you're right? Yep, okay. So with any of these, with a lot of these further expansions, it'll be using some of the rules we knew before. All right, so either your perfect squares or any of those. And so what you're doing here is you're just remembering to multiply that by everything and then multiply that by everything. The only problem I guess you'll have is when there's some negative signs in here. Okay, so remember that's x times x squared being x cubed and x times negative x being negative x squared. All right, so provided you are chasing those signs with the thing that comes after it, that's one thing to remember. The other thing to discuss here will be there's some of distributive law 1 there. Yeah, all right, and you just leave this alone. So work from left to right, doing your distributive law first, and that just comes straight down. Does that make sense? So don't try and do it all at once, is what I'm saying. When you get to these, okay, are you up to these yet?
No.
No. So let's just have a look how we might do this first one. All right, what would we do with the x there, Lee?
Times by x squared.
Yep, anything else? No, so let's start by that. So x times x squared gives us
X cubed.
x cubed. Good, what would we do next, Lee?
And then x times positive x.
Good, x times positive x would give us,
X squared.
yes,
And then x times positive 1 would equal x.
good, so we're left with that. Yep. And then the next thing we would do, Garrett?
Negative x times
Negative x. Negative x. Did you say?
negative 1
Negative 1.
times x squared.
Good. So everything, again, is multiplied by here, there, and there. So we've got negative 1 times x squared gives us,
Negative x squared.
yes. And the next one,
Negative x.
yes. And the next one,
Negative 1.
good. Negative 1. And then it's a case of collecting our like terms. We have nothing else that's cubed, so that's going to come straight down. We've got an x squared, take an x squared. They cancel each other out. We've got an x, take an x. They cancel each other out. That leaves us with take 1. Yeah?
Yeah.
Okay. You're going to find a pattern soon. When you get to this one, you're going to find a pattern occurring with the answers. It's your challenge, if you like, to identify what the pattern is, and what you'll end up doing is you'll end up making your own rule, because a rule exists when you're multiplying this sort of system that you'll soon find. Okay, so that's the great challenge of 5, which some of the other group are up to. So they're challenged by that. You will be challenged, but just think about all that you learn above it. Don't do this, because I know you both like challenges. Don't do this before you know the stuff prior to it. Where you're working left to right, do the distributive law first and drag everything else down until you can get to that distributive law.
Because you can already see like a pattern going on. Like with I, it's like x take negative 1, which is always the same.
That's
And and then you've got the like plus 1 and then it's rising. So
Okay.
the x is equal and x is equal.
Maybe. All right. So you're right with that?
Yeah.
Okay. Cool. A and E. Yep. Okay. So it's a matter of like reading a book, reading from left to right. Okay. So what I'd do here is not even worry about the fact that that's there at this stage, and say, do I have to do anything with that? Okay. It's really easily evident that no, you don't have to. So you'd go away and you'd straight away write 2x plus 1. And then you'd start your distributive law here. Okay, so how would you go about starting your distributive law there? It could be. Let's try that, shall we? What else could it be? We're just going to check out 2 ways of doing it. What else could it be? So I assume you've squared this because you've squared that. You're using distributive law, perfect squares. So could it not be take x squared because of that? Could it be?
It could be, but obviously because of the way negatives go from
Yep. Let's just put that down, shall we?
Yeah.
All right, we're rolling with this. So we've done that. Yep. What else do we have to do now? Add 2 times x times 2. And what could it be here? Could be take 2 times x times 2, couldn't it? Yep, alright. And then what is left to do? Yep, it could be add 2 squared, or it could be take 2 squared. Yeah. Alright, let's have a look. So we'll bring the 2x plus 1 down straight away, plus x squared, and then we can do this, plus 4x, plus 4. Yeah? Alright, and then we go about collecting like terms. That is a like term with that. That is on its own, and that are like, don't they? And we try and put the x squareds out the front, don't we? Yep. So it'll be x squared 6x plus 5. So it could be x squared plus 6x plus 5. Alright. Alternatively, let's see if it might be this. 2x plus 1 take x squared. So negative 2 times 2 is negative 4x. Negative 2 times 2 times x, yep. And then negative 2 all squared might be positive 4. Okay. Looking again for our like terms. I shouldn't have written that. What are our like terms there, mate? Is that like to anything? No, so we pull it down. Is there anything like to 2x? There's nothing like with 2x. Yep, so 2x take 4x. And then what does that leave us with? 1 plus 4 is 5. Alright. Check your answers, see what you got. Which one's the answer? Or is there an answer that we've got up there, or do we need to look at it again? Yep. For this one? Or this one? Yeah. Okay, so what do you think they've done to get take 3 here? Yep. So what they're saying there is you can square the 2, but it's going to be take that number. Yeah? And it's going to be take that number because you have this out the front. So it's going to be a negative whatever that square is.
what I'm trying to do is enrich and deepen your learning